Assalamualaikum guys, I'm back again with another video, and this video is the second video on the topic of statistics, and second in the series of videos that we have done on frequency distributions. The first video that we uploaded some time back was just how you create a frequency distribution table. In this video we'll be looking at how to do a cumulative frequency and then relative cumulative frequency distributions. So what is cumulative frequency? What we'll do is, before we get into that, we'll just do a quick recap of the frequency distribution. Now, and the main topics that we discussed in the earlier video. The frequency distribution is a table that displays the frequency of various outcomes in a sample. Okay. Each entry in the table contains a frequency or the count of occurrences or the values within the particular group or an interval. The frequency distribution summarizes the distribution of the values in the sample. Now, what is the cumulative frequency? The cumulative frequency distribution is a summary of data frequencies above or below a given level. So let's look at an example to understand this more clearly. And also, since we'll be actually solving the problem, we will also get a more hands-on on how to do the cumulative frequency distribution. Here we have a frequency distribution table already constructed for us. We have the lower limits, the upper limits, and the frequencies. Now, how do we fill in the cumulative frequency? For the first row, the cumulative frequency is the same as the frequency itself. So the first row, the frequency was 2, so the cumulative frequency is going to be 2. Now, for the second row, what you do is you take the row above it and the row that you're on, and you add them together. So it's going to be 2 plus 2 gives you 4. So the cumulative frequency for the second row is going to be 4. Now in the third row is going to be the frequency of that row plus all the frequencies in the rows above it. So it's going to be 2 plus 2 plus 6, which will give you 10. Okay, so once again, the row on which you're on, you take the frequency of that row and you add all the frequencies above it. So it's 6 plus 2 plus 2 gives you 10. Now for the fourth row, using the same principle, it's going to be 4 plus 6 plus 2 plus 2. So 4 plus 6 is 10, and plus 2 is 12, and plus 2 14. So the cumulative frequency for the fourth row is 14. Now let's look at the fifth row. It's going to be 1. The current row is 1 plus everything above it. So 1 plus 4 is 5, plus 6 is 11, plus 2 is 13, plus 2 is 15. So cumulative frequency for the fifth row is 15. And the last one is going to be 18, so it's going to be 3 plus 1 plus 4 plus 6 plus 2 plus 2 is 18. So that's how you would do a cumulative frequency, fill in the cumulative frequency. Just to recap, for every row, the cumulative frequency is the frequency of that row plus the frequencies of all the rows above it. Okay. Now, the next topic that we're going to be discussing today is the relative cumulative frequency. Okay, so we will not. I'm just going to skip over these definitions of frequency distribution and jump straight to the definition or explanation of what is relative cumulative frequency. Now, as you can see on the screen, the relative cumulative frequency distribution is the quotient between the cumulative frequency of a particular value and the total number of data, and it can be expressed as a fraction or as a percentage. Usually it is expressed as a percentage. Now what we'll do is, as we did in the earlier example for cumulative, we will actually go through and fill in the relative cumulative frequency values. So we're going to be using the same example. We have the lower limits, the upper limit frequency, and the cumulative frequency already filled in for us. The total frequencies is 18, and that is a quick way to make sure that we have not made any mathematical errors, because the sum of the frequencies, which is in this case 18, should equal to the last cumulative frequency, which is also 18. If these two numbers don't match up, that's a quick pointer to you that you have made an addition mistake somewhere along the line. So you should always go back and recheck your math. Okay, now the cumulative frequency, we'll be looking at and filling in that column. The first cumulative frequency is 2, and you divide that by the total frequencies. So that's 18 in this example. So 2 divided by 18 gives you 11.1%. Like I had said earlier, it can be shown as a fraction or as a percentage. We tend to display it or tend to express it as a percentage more often than as a fraction. Now, for the second row is going to be 4 divided by 18. Again, 18 is the total number of frequencies. So that turns out to be 22.2%. Now in the third row, the cumulative frequency is 10. So 10 divided by 18 would give you 55.6%. Similarly, for the fourth row, 14 divided by 18 would give you 77.8%. Fifth row is going to be 15 divided by 18 is 83.8%, and the last one, 18 divided by 18 is 100%. Now, another quick way to make sure that you have not made any arithmetic mistakes is each subsequent relative cumulative frequency needs to be larger than the previous one. Number one. Number two, the last relative cumulative frequency would always be 100%. Reason being, the total number of frequencies is the same as the cumulative frequency of the last entry, last row. So when you take 18 divided by 18, you will always get 100%. Or the value of 18 may be different, but the total frequency, the total of all the frequencies, the sum of all the frequencies, and the last cumulative frequency would always be the same, and so when you divide that by each of them, you get 100%. So just a quick recap: each subsequent relative cumulative frequency needs to be higher than the previous one, and the last one needs to be always 100%. So very simple concept. We just talked about how you do a cumulative frequency, and now we have just discussed how to do a relative cumulative frequency. The cumulative frequency was shown as numbers, as opposed to the relative cumulative frequency, which can be shown as fractions or as percentages, and more often we tend to show them as percentages. So that was that we're going to end this video here. I hope you liked this video, and if you did, please kindly give it a thumbs up, and I would also request that you support the channel by subscribing. Thank you very much, and see you next time.